Welcome to another video, and today I want to show you my script which can actually cut ceilings and walls. And you probably know, if you ever model some architect model, that after you create ceilings and walls, and in some moment when you have columns, you will need basically to edit all those elements. So for the ceilings you will need to create boundaries around the elements, and when you finish with creating the boundaries, now you can see that you did avoid that clash. And also, if you check the area before and after, the area for this ceiling and for all other ceilings will reduce, so you will have more accurate BOQ. But if you have like 5 columns, that is easy task, and you will not probably run the Dynamo for that. But when you have 100 or more columns and walls and you need to do task over and over again, it is very boring and time consuming. So for my future projects and for my future models, I did create this script. I will undo this creation of the boundaries. And now if we check the area is 28.5 square meters. And when we run the script, we will also reduce the area for the walls. So here we have 35.2 square meters for area. And I have two examples to show you. But in this example, we have some walls, and I did randomly place those columns, and this column I did rotate by some angle to see how the script will perform. Over here, again, I have 5 different columns. Columns have different sizes, and also they are rotated by some random angle. Over here we have 2 standard columns, and one of them is rotated by 90 degrees. And here I did want to see if I have 2 ceilings and 1 element, if my script will be able to resolve this. And also, in order to confuse the Dynamo, I did insert some column which will not interfere with any ceiling or the wall. And now if we run the script, and the script does not have any user interface, it will basically just look for the wall, ceilings and the columns, and if it finds interference, it will void that area. So now if we select all the ceilings and isolate them, you can see that the script did perform a very good job. And also if we take a look walls, also again we did reduce the volume and the area. We used to have here 28.5 square meters. Now we have 1 square meter less. Over here we did say that we have 35 square meters. I think now we have 3 square meters less. And that is basic benefit from this script. If you run a collision detection in the navies or inside the Revit, you will not have now those collisions, and we can check that. No interference detected. Also, if we take a look some other example, what we have here, we have some walls, columns, beams, and that's it basically. And also I did like split the ceiling in one moment, so one portion of the ceiling needs to be cut from this side and the other part of the ceiling needs to be cut from the other side. And also if you take a look, I did choose that this ceiling will be on the elevation 2.6 meter, and this ceiling over here will be on the elevation 2.8 meters. If we hide those ceilings for the moment, over here we have some walls, and over here also our script needs to cut this portion of the wall which is in interference with the column. And let's see if the script can do that. So now if you take a look the output from our script, so for example, if we turn off the visibility for all other elements except ceiling and columns, we can see that everywhere where we did have interference, our script performed well. And if we isolate our ceilings, you can see here, here, and here that the edges of the ceilings, that also the script did void those parts, and that is okay. Now let's exclude the ceilings and turn on the walls. So if you remember, we did have one entire wall here. Now we did reduce the area and the volume as we did for the ceilings, and you don't need to split this part to 3 different parts, and over here we have same situation. So now the script completed that entire job for us. Even in this situation, when you have walls which need to go by some angle, it will be splitted. Okay, and basically that's it. Now we will go to Dynamo and I will show you the script. This upper part of the script is reserved for the ceilings, and this part down here is reserved for the walls. And basically the logic is pretty much similar, but while I was dealing with that second part for the walls, I did even optimize some tasks in those groups. So first of all, we need to check how many columns and structural columns we have inside our project, and we will call all elements of category. So we can see that in this example we have 21 different elements for the columns. We have only 2 ceilings, and from here we will convert elements to solids, and this is like a key node inside entire script. This will basically create a list of interference which we have inside the project. And now before we go further, I will show you that this script will use some simple void family. When we find interference between some ceiling and between some column, we will automatically place on that spot our void family, and later we will check if we need to rotate that family, and we will rotate, adjust all those parameters regarding the size of that void, and at the end we will basically cut this void family with the ceiling, and at the end of the script we will hide all those elements. So yes, basically those elements will be like some trash in our models, but I think this is the only way to cut the ceiling inside Revit, because with Revit API limitation regarding the ceilings, I'm pretty sure that there is no other way to reduce the area of the ceilings, and that is why we need to create some extra elements in order to have those benefits for the walls and the ceilings. And now let's go step by step. So we did find interference between the columns and the beams. Now we want to check all columns and all ceilings, and we will have some empty parts of the list. We want to check that to create a filter, and we will proceed. This part over here we will need at the moment when we need to adjust the height for the void, and that is why we want to ask this basically the ceiling to provide us information regarding the height. We will take that height and later send it to the families for voids, and you can see over here that we have that difference in elevation. So basically after the filter we will jump to the mesh, and the really cool thing with using a mesh is that mesh will very easily give you all vertices and all the points on the edges, and usually you will have like twice the points, because there will be the difference in the height, so you will have the same points just on different elevation, and that is why I will create X and Y points again, and I will prune the duplicates. So over here I have like 8 points, but I know the trick. I know that those are just 4 points just on different elevations. And now this part over here, it's a more mathematical problem than a problem for the Dynamo. Now we know the location where we need to place our void, but we also need to check the rotation and the size of that void. Oh, let's see what we have here. So if we have any column, this will be our column. And now, because we did ask for the mesh and all the points on the edges, so we have all those points over here. And because we did convert all the columns to be a solid, we also know that center point. And now how we will determine what is the vector of this column in order to rotate our elements, and also we need information regarding the size. So how we will determine all those information? Well, my logic is that I will pick one point. For example, I will pick this point, and now I want to create some lines, and later in the script I will say, okay, use this point and go over here. So I will have one line. Then I will say, okay, do this and do this. And after I have all those lines, I can easily read the length of those lines. Now the real problem is if we want to know the direction of the column, if we want to know the vector, we need either this vector over here or this vector over here. It is a key thing to not pick up this line over here. The shortest distance is always the normal distance. So basically, if I did project all those three lines, I know that my shortest distance will be either this distance over here or this distance over here. The diagonal distance will always be greater than these two distances. So I did project all those lines. I will read the length, and I will ask for the minimal item inside the list. And that is how I will probably pick these 2 points, and from this point I will know the direction of my column. I will cross-check that with X or Y axis, and that is how I will know this angle over here. That is the part for the angle. And the second part, now when I know the angle, I will rotate this column in order to have information for the size. I will rotate that, convert that to bounding box, and from that point I will easily read end point and start point. From that point everything is clear regarding the size. So I did choose 3 different points. I did create some number of lines, and now I'm asking for the length of those lines. And now the logic is to pick that lower value. Now I will convert that to vector, and I will compare that direction with the y-axis, and from this point I will have the angle for all columns. And now this part over here is actually trial and error situation where I did trim this situation here to cover all possible situation which I cannot imagine. And from this moment over here, I will check and see that inside my project that only 2 voids need to be rotated. So as we said, the script will just create voids and then it will place them on the correct location. And the third part is the check if that void need to be rotated. So we can see over here that only these 2 columns have some rotation, and only in those 2 situations we will need to rotate our voids. And those are the values for the angle, and we will deliver that to this node over here, and we will rotate just those 2 voids. Over here, as we said, we want to adjust the height of the void. So we will take the central point of our column because x and y points will be the points in which we need to place our voids. But regarding the height, we will take that information from the ceiling. So if we go backwards. So from the ceiling we will take the Z point and deliver that to the new point for the void location. Now when we placed void correctly and rotate the voids, now we need to determine the size of the void. So we will rotate the solid part of the family. We will not rotate the family itself. And when we now rotate the family, we want to read minimal and maximum point from the bounding box. And from that point, it is very easy to read all the information regarding the size of the columns. Because in different situations we have both negative and positive values, I did insert this absolute node to make sure that my values will always be positive. Also, because we have some float numbers with some number of decimals, I want to convert that to integer. And later, as you did spot probably before, our void family have those parameters a, b for the length and width, and this c half parameter is dedicated for the height. And now when we know the size of the void, we now can say that the void will be our cutting element, our ceilings will be elements to cut, and we will cut that geometry. And later on, when we create basically the same results for the walls, we will deliver all those voids to the one list, and we will hide those voids because there is no purpose to see them inside the view. And for the wall, it's pretty much the same story. Again, we will cut our walls by the same elements, by the columns or structural columns. We want to convert both sides to the solid. We want to perform that intercept action. From that point, we need to position our voids correctly, and again we need to check if the columns inside the walls have some rotation. So again we will go to the mesh, find the points. Again, the logic for discovering the vector for all the columns is the same. We will track some 3 different points, create 2 lines, find the line which have the minimal length. We will declare those values to be the values for our direction. We will compare that now with the x-axis, and we will have all the angles. Basically, we don't have any columns, and we don't need to apply any rotation in this sample file. As we said previously, this part over here, it's basically the part in which we need to determine the location for the void. So now we did determine that there is no need to perform rotation for the voids. We just place them correctly by the x, y, and z coordinates. If you have some rotation of the wall like we did have on the first example, you will again rotate only those solid parts inside the dynamo, transfer all that to the bounding box, find the minimal and maximum point. From that point, again, you will easily receive the information regarding the size. You will deliver all that to the family of the void, and again the cutting elements will be the void elements to cut will be wall elements. We need to send all of that to our total list of the void elements in order to hide them. And basically that's it. That is entire script. I didn't test this script on some large scale projects, so probably I will need to improve this script in time, but I think this is a good base for the similar scripts. Thank you for watching. Bye.